In previous video, we discussed the definition of PM and FM. That is, has this general format: U of t equals AC cosine 2 pi of c plus phi of t. And phi of t has different definition for PM and FM. For PM, phi of t equals kp mt, and FM equals 2 pi kf. We do the integral of the message. FM and PM are both called angle modulation. There are some terminologies we need to know about angle modulation. The first is Kp, is called phase deviation constant. Kf, that's a frequency deviation constant. So I put these two together, the pair for PM and FM for the deviation constant. Next, we discuss the maximum phase deviation and maximum frequency deviation. So maximum phase deviation delta phi max, that equals to Kp multiplied by maximum value of the absolute value of mt. So this can come from here. In phase modulation, Kpmt, that is the quantity of the phase of the carrier will change with the message. Then what is the maximum phase deviation? Then we need to take the absolute value of the message and multiply by Kp. The physical meaning of maximum phase deviation is the maximum phase change in the PM modulation caused by the message. So this change, this phase change, has been caused by the message, and there is a maximum values, maximum quantities for the phase change. It is a Kp maximum, the absolute value of mt. Next, let's look at the maximum frequency deviation for FM modulation. The symbol is delta F, that's one symbol, max, which means maximum value, is equals to Kf multiplied by the maximum value of the message, mt. Why is this? We need to look at the instantaneous frequency for FM. So instantaneous frequency, we take 1 over 2 pi derivative of the angle, that's this term, that equals EFC, plus 1 over 2 pi derivative of phi with respect to t. d phi dt is here. This equals 2 pi kf mt. So plug it in, the instantaneous frequency for FM is equals fc plus kf mt. So therefore, the maximum frequency change caused by the message is this term. It's determined by this term kf mt. But because the message can be positive and negative, so we take the absolute value and we take the maximum multiplied by kf. So this is the physical meaning of the maximum frequency deviation. Next, let's look at the modulation index beta for PM and FM. For PM, beta equals to maximum phase deviation. For the FM, the modulation index is equals to maximum frequency deviation divided by the bandwidth of the message. Modulation index beta is a very important parameter for the angle modulation because it determines the bandwidth of the PM and FM modulation. In separate video, we're going to show that the bandwidth for the angle modulation, either FM or PM, the bandwidth in theory is infinity. We need to look at an effective bandwidth for the angle modulation. And this bandwidth is determined by Carson's rule. The bandwidth of FM or PM that equals to double of beta plus 1 multiplied by the bandwidth of the message. Because beta is positive, so therefore this quantity will greater than 2W. So this is greater than double sideband AM modulation. Let's think about FM radio and AM radio. The sound, the music quality is come from the FM radio sounds much better than AM radio. That is because FM modulation or angle modulation has better capability for the noise immunity, which means that the noise will affect more AM modulation than the FM modulation. Next, let's look at an example. The message signal here is equals to EMT equals to small a cosine 2 pi FMT, and FM equals to 8 Hertz. The carrier is equals to C of T AC cosine 2 pi CT. We want to use angle modulation. So this is the general form for angle modulation. First, let's look at the PM. The PM, I want to use Kp equals to 10 is given. Let's see what is the maximum phase deviation. Theta phi max. That equals to Kp max of absolute value of M of T. And if we want to set small a equals to 10, we know Kp equals to 10. Max of absolute value of EMT, that equals to A, which is equals A equals to 10. I set it up, and then multiply 10 equals to 100. So this is the maximum phase deviation. The unit will be radians. Next, let's find out the modulation index beta. Modulation index beta equals theta phi max for PM. And this is exactly here. And this equals to 100. Right? Then what is the effective bandwidth? Effective bandwidth, according to Carson's rule, as 2 beta plus 1 equals to W. W is the bandwidth of the message. The bandwidth of the message is FM. So 2, 100 plus 1 multiplied by 8. Whatever it is, that's 111 multiplied by 16. This is a 4 PM. 4 PM. So next, let's look at the for FM. So the same message, but this time I want to use FM now. I do not want to use PM. This is the same carrier. Then what is the maximum frequency deviation? Theta F max. That equals to KF multiplied by max of MFT. Maximum frequency deviation, that equals to KF max of absolute value of EMT. That equals to KF equals to 20. 20 multiplied by 10, that's equals to 200. The unit here should be Hertz because we talk about maximum frequency deviation. Now, then what is a modulation index? Modulation index is for the FM equals to maximum frequency deviation divided by the bandwidth of the signal. So that will equal to theta F max divided by W, that will be 200 divided by 8. Right? 8, that's the bandwidth of the message. Now then, what is the effective bandwidth? Carson's rule. 2, in this case, 200 divided by 8 plus 1 multiplied by 8. It cancel out each other. So first term, yes, equals to 400 and plus this one, 16, that's 416. So that's the effective bandwidth for FM. Now let's think about if for the same message, if I use DSB SC AM modulation. What's the bandwidth of the modulated signal? So the bandwidth of the modulated signal is 2W. That equals 2 multiplied by 8. That equals only 16 Hertz. For the PM and FM, the bandwidth for the modulated signal is much bigger than the DSB SC AM signal. And this is the Hertz, and this is the Hertz.